Hi guys, welcome to physics class by Isaiah, and today we'll be looking at temperature, and specific heat capacity. Temperature and specific heat capacity. So first thing, we need to understand what heat is all about. So heat, in this case, is just the total internal energy of the system. The total internal energy of the system. For instance, let's assume that this is a body, and inside the body we have 4 basic particles like this that make up the body. Just an assumption. So now every particles has a certain amount of energy that it contains. So here, let's say here is 5 joule of energy, here is 10 joule of energy, here is 15 joule, and here is 20 joule. So in this case, if I want to divide heat now, heat is just the sum of the total internal energy. That is, aside from the energy that are present in this body, there might be some other tiny energy that cause disorderliness, that many things. All the energy summed together. So let's just assume that the ones we can see, leave it. So all the energies summed together is the heat. Now, in this case, now we now want to divide the temperature, which most people always define as the degree of hotness or coldness of the body. Well, that is correct, but with respect to a physical representation like this, temperature is not just the degree of hotness or coldness. Temperature is now, you see, these guys, they contain an energy, and one of the energy is kinetic energy. That is the energy that describe the tendency of their movement. They can be vibrating. These particles always try to move. So let's assume that these energies that I'm marking, they are the kinetic energy. So the average kinetic energy, when I say average, it means the mean. You understand? Just like it's the simple mathematics where you had all the energy together and you divide it by how many are they? 1, 2, 3, 4. You divide it by 4. So the mean of that energy, the average kinetic energy, the particles in a system, is called the temperature. So that means when you place your thermometer right there on this body, what thermometer does is that it does this calculation behind that you don't see. So it just takes the sample of the kinetic energy of all the systems, they add them together and divide it by their total. So in this case now, we have a kind of 12, that is 12.5. You understand? 12.5. So that's the average kinetic energy that we have regarding this. Now, what we call heat capacity now. Heat capacity. Now, imagine that I have a task of increasing this thing I call temperature. Don't forget, I use the word joule, and this is not always the case. Most temperatures are measured in Celsius, Fahrenheit, and Kelvin, depending on the area you are looking at. So there's a conversion from joule, the energy, to this. So let's just assume that these are in joule now. So that means we have 12.5 Kelvin or Celsius. Now, what heat capacity is all about is that, okay, what amount of energy can you add to this system entirely that will change this temperature from being 12.5 to 13.5? That is, it will make it increase. Let me change this back to Kelvin so that it can work. Kelvin is the standard temperature. So what amount of heat will you add to this entire system that will not change it from 12.5 Kelvin to 13.5 Kelvin? So that shows that I'm coming back here now. Instead of 50, what if I add 4 to it and make it 54? So if I divide 54 by 4, I'm going to be getting 13.5 joule. You understand? So that's why heat capacity, so that means these 4 that I added to this entire system, now these 4 joule that I added to it, that now increase it from initially 13.5 to from initially 12.5 to 13.5. That is what I called heat capacity. So if you want to define that, you say heat capacity, the amount of heat required to raise the temperature of the system or the body by 1 Kelvin. So if we go to specific heat capacity, just like the word says, specific, so they want you to be specific about the body. In heat capacity, we just call it body, but in specific heat capacity, you specify and say a unit mass. You say a unit mass. So now in this case, that means maybe 1 kilogram mass of this. Now I want to increase temperature by 1 Kelvin. So just the same thing. The heat capacity and specific capacity are almost the same thing, except that instead of just saying a body or a system, you have to specify by saying the amount of heat required to raise the temperature of a unit mass by 1 Kelvin. That is specific heat capacity. Thank you.